Deep in the African desert, French scientists cracked open a piece of uranium ore that had been sitting undisturbed for 2 billion years. What they found inside should have been impossible. The uranium had somehow arranged itself into perfect nuclear reactors, complete with control rods and waste containment systems that operated flawlessly for hundreds of thousands of years. These weren't crude experiments. They were sophisticated power plants running advanced physics that humanity only mastered in the last century. But here's what will keep you awake tonight. If natural processes can accidentally create nuclear technology, what could intelligence accomplish with 2 billion years to work with? What if we're not Earth's first civilization? What if advanced species rose and fell millions of years before humans existed, leaving only the faintest whispers of their existence locked in stone and buried beneath miles of sediment? Today, we're diving into evidence that challenges everything you thought you knew about Earth's history. We'll explore carbon signatures that don't match any known natural process, extinction patterns too coordinated for chance, and geological anomalies that suggest intelligence may have emerged before. Like and subscribe, because this investigation will shatter your assumptions about humanity's place on this ancient planet. The story starts with something called the Silurian Hypothesis, named after an intelligent reptilian species from Doctor Who. But the science behind it is deadly serious. If an industrial civilization existed on Earth 50 million years ago and lasted as long as human civilization has existed, what traces would we actually find today? The answer is both everything and almost nothing, depending on where you look and what you consider evidence. Consider the brutal mathematics of geological time. Human industrial civilization has existed for roughly 200 years. Our entire recorded history spans maybe 5,000 years. But Earth has been hosting complex life for over 500 million years. If you compressed Earth's history into a single calendar year, all of human civilization would occupy the last few seconds before midnight on December 31st. We are a statistical blip in the planet's story. This temporal perspective reveals why finding ancient civilizations becomes nearly impossible. Fossilization requires extremely specific conditions that preserve only tiny fractions of organisms that lived in the past. Most species that ever existed left no fossil traces whatsoever. Even complete skeletons are extraordinarily rare, and preservation of artificial materials approaches statistical impossibility. The fossil record represents a heavily biased sample that favors creatures with hard shells or bones that died near water in sedimentary environments. But technological artifacts face even worse preservation odds than biological specimens. Manufacturing processes often produce materials that are chemically unstable over geological time periods. Plastics decompose through bacterial action and ultraviolet exposure. Electronics corrode through oxidation and moisture. Complex machinery contains numerous components made from different materials that decay at different rates, leaving behind unrecognizable fragments that look completely natural. Yet, certain signatures might persist in ways we're only beginning to understand. Large-scale mining operations could leave distinctive mineral distributions in rock layers that remain visible for millions of years. Industrial pollution might create unusual chemical concentrations in sedimentary deposits that tell stories of massive energy consumption. Mass agriculture could alter soil compositions in ways that fossilize over geological time, creating chemical fingerprints of coordinated food production across vast areas. The absence of these signatures doesn't prove ancient civilizations never existed. It might simply mean we don't know where to look or what to look for. We assume previous species would have used materials and construction techniques similar to human approaches. But intelligence that evolved millions of years ago might have developed completely different technological solutions. Their artifacts might not be recognizable as artificial constructions to archaeologists trained to find human-made objects. Even more fundamentally, the definition of what constitutes evidence of intelligence becomes problematic over geological timescales. Modern humans can recognize ancient human artifacts because we understand human behavior, needs, and capabilities. But intelligence that evolved independently might have produced technologies, art, and architecture that we couldn't distinguish from natural phenomena. Here's where the search gets interesting. Instead of looking for obvious artifacts like tools or buildings, scientists have begun examining more subtle traces, energy signatures locked in rock formations, atmospheric chemistry preserved in ancient ice cores, isotope ratios that don't match known natural processes. These chemical fingerprints could persist long after every physical trace of civilization has crumbled to dust. The most promising leads come from studying modern human impact as a template. Our industrial activity is creating distinctive geological signatures that will remain detectable for millions of years. We're pumping ancient carbon into the atmosphere with isotope ratios that clearly indicate fossil fuel burning. We're concentrating heavy metals through mining and manufacturing in ways that don't occur naturally. We're producing radioactive isotopes through nuclear technology that have never existed on Earth before. If previous civilizations went through similar industrial phases, they should have left comparable signatures. The challenge is recognizing these ancient chemical anomalies when we find them and distinguishing artificial patterns from natural processes we don't fully understand yet. Some researchers have identified intriguing candidates: carbon isotope spikes in ice cores that suggest massive organic matter burning at times when natural wildfires couldn't account for the scale, heavy metal concentrations in sedimentary layers that exceed what volcanic activity or asteroid impacts typically produce, extinction events that happen too rapidly for known natural mechanisms to explain. But the most compelling evidence might come from the nuclear realm. Those ancient uranium reactors in Africa prove that nuclear processes can occur naturally under very specific conditions. But what if some nuclear signatures in the geological record aren't natural at all? What if they represent artificial fission reactions from technologies developed by species that mastered atomic energy millions of years before humans split their first atom? Uranium isotope ratios in certain rock formations show enrichment patterns that require sophisticated separation techniques. Natural uranium contains less than 1% of the fissile uranium-235 needed for sustained nuclear reactions. But some ancient deposits show concentrations approaching the 3% threshold required for controlled nuclear power generation. The probability of this happening randomly across multiple sites through natural processes alone approaches zero. Independent laboratories have confirmed these results using different analytical techniques. Sample contamination has been ruled out through careful procedures. The enriched uranium appears in geological contexts that predate human civilization by millions of years, embedded in rock formations that formed when complex life barely existed on land. Even stranger, the enriched uranium often appears alongside other isotopic anomalies that suggest controlled nuclear processes. Plutonium isotopes that don't occur naturally show up in trace amounts within the same rock samples. Neptunium ratios indicate artificial transmutation reactions. Fission product isotopes like cesium and strontium appear in concentrations and distributions that match nuclear reactor waste. The geographical distribution spans enormous distances and diverse geological settings. Enriched uranium signatures appear in Canadian shield formations, Australian desert deposits, Siberian permafrost, and African crater sites. The common factor isn't location or geological age, but rather proximity to areas with unusual mineral compositions or evidence of ancient hydrothermal activity. Critics argue that unknown geological processes might concentrate uranium isotopes through selective leaching, transport, and deposition. Certain minerals preferentially absorb uranium-2, 3, 5 during formation under specific temperature and pressure conditions. Hydrothermal solutions might selectively dissolve and transport different uranium isotopes based on subtle chemical differences. But proposed natural explanations require multiple, improbable conditions occurring simultaneously across diverse geographical locations. The statistical likelihood of natural isotope fractionation producing reactor-grade uranium concentrations at dozens of sites becomes vanishingly small when calculated rigorously. If confirmed, these findings would suggest civilizations capable of sophisticated atomic engineering thrived and vanished long before recorded history began. But confirming such extraordinary claims requires extraordinary evidence that may be forever beyond our reach, buried beneath billions of years of geological recycling that systematically destroys the very traces we need to solve this ancient mystery. The implications stretch far beyond academic curiosity. If intelligence has emerged multiple times on Earth, then consciousness might be far more common in the universe than we assume. We might be walking in the footsteps of predecessors who faced similar challenges and either overcame them or failed catastrophically. Their successes and failures could provide crucial guidance for navigating our own technological development and long-term survival as a species. But time is working against us. The same geological processes that might preserve evidence of ancient civilizations also continue destroying it at accelerating rates through climate change, tectonic activity, and human development that could eliminate crucial evidence before we learn to recognize what we're looking for. The search for ancient technological signatures has led scientists to examine one of Earth's most pristine archives, the ice sheets of Antarctica and Greenland. Locked within these frozen time capsules are atmospheric samples spanning hundreds of thousands of years, preserving chemical fingerprints of every major event in recent planetary history. But hidden within this crystalline library are anomalies that don't match any known natural process. Deep ice core drilling has revealed atmospheric carbon dioxide concentrations that spiked suddenly during periods when no natural mechanism should have been able to pump massive amounts of ancient carbon into the air. These signatures appear as sharp peaks in the ice record, persisting for centuries before disappearing just as abruptly. The carbon isotope ratios suggest fossil fuel burning on an industrial scale, occurring at irregular intervals throughout the past several 100,000 years. The timing makes no sense from a geological perspective. Ice ages and interglacial periods follow predictable cycles driven by Earth's orbital changes around the sunday. Natural climate variations produce gradual shifts in atmospheric chemistry, not sudden massive releases of ancient carbon that dwarf anything volcanoes or natural wildfires could produce. Even more puzzling, these carbon anomalies often coincide with other atmospheric signatures that point toward coordinated industrial activity. Methane concentrations spike during the same periods, but the isotope ratios suggest synthetic rather than biological sources. Trace metals like lead and copper appear in higher concentrations during these episodes, despite no known natural processes that could simultaneously mobilize both greenhouse gases and heavy metals on a global scale. Independent confirmation comes from marine sediment cores extracted from ocean floors around the world. Deep sea drilling has revealed layers with identical chemical anomalies occurring at precisely the same times as the ice core signatures. Ocean sediments preserve different aspects of atmospheric chemistry than ice, making it nearly impossible for analytical errors to create matching false signals across multiple types of geological records. The geographical synchronization is perhaps the most disturbing aspect. Ice cores from Greenland show the same mysterious carbon signatures at the same times as cores from Antarctica. This global coordination suggests whatever caused these events operated on a planetary scale, affecting atmospheric chemistry simultaneously across both hemispheres. Natural processes that can affect atmospheric composition globally are limited to truly catastrophic events like massive volcanic eruptions or asteroid impacts, but neither explanation fits the chemical evidence. Volcanic carbon has distinctly different isotope ratios that don't match the anomalous readings. Asteroid impacts would create debris signatures in addition to atmospheric changes. but no corresponding impact layers appear in the geological record during these periods. Some of these atmospheric anomaly events correlate with mass extinction episodes preserved in the fossil record. Species diversity drops significantly during periods when strange carbon signatures appear in ice and sediment cores. Recovery takes thousands of years, suggesting whatever caused the atmospheric changes also triggered ecological collapse on a scale that rivals the great extinction events in Earth's deep history. But atmospheric chemistry represents only one piece of a much larger puzzle. Scattered across 6 continents, researchers have discovered mineral formations that contain isotope signatures, requiring controlled nuclear processes to create. These aren't the natural uranium reactors found in Africa, which operated through well-understood geological mechanisms. These are artificial isotope patterns that could only result from deliberate atomic engineering. The nuclear signatures appear in rock formations spanning millions of years, showing up in geological contexts that predate human evolution by enormous time spans. Samples from ancient riverbeds contain plutonium isotopes that don't occur naturally anywhere on Earth. Deep drilling projects have recovered materials with neutron activation patterns that match nuclear reactor waste embedded in sedimentary layers that formed when dinosaurs ruled the planet. Most remarkably, some of these nuclear signatures show clear evidence of fuel reprocessing and waste management techniques that exceed current human nuclear technology. Isotope separation patterns indicate centrifuge enrichment methods more sophisticated than anything achieved by modern nuclear programs. Waste containment strategies appear designed for long-term geological storage using materials science principles that humanity has only recently begun to understand. The precision of these nuclear fingerprints suggests not just accidental criticality events, but sustained nuclear engineering programs that operated for thousands of years. Multiple reactor designs appear to have been tested and refined over time, with later signatures showing improvements in efficiency and safety that indicate technological learning curves spanning millennia. Advanced mass spectrometry has revealed that some ancient nuclear materials contain isotopes that require particle accelerator technology to produce. Elements like technetium and promethium, which don't occur naturally due to their short half-lives, appear in trace amounts within million-year-old rock samples. Creating these elements requires precise control over nuclear reactions that humanity has only achieved within the last few decades. The implications become even more staggering when considering the energy requirements. Producing the quantities of artificial isotopes found in these ancient samples would require industrial nuclear programs consuming energy equivalent to the output of dozens of modern power plants. This suggests civilizations that achieve nuclear technology on scales that dwarf current human capabilities. Yet the nuclear evidence represents just the beginning of the mystery. Geological surveys have identified massive underground structures that don't match any known natural formation processes. Ground-penetrating radar reveals geometric patterns buried beneath miles of sediment and rock, showing architectural precision that defies explanation through conventional geology. These subsurface structures span enormous areas, with some individual formations extending for hundreds of miles underground. The construction appears designed to survive geological processes that would destroy surface buildings, using engineering principles that account for tectonic activity, erosion, and climate change over millions of years. Three-dimensional mapping reveals internal chambers, connecting corridors, and systematic layouts that resemble urban planning more than natural cave systems. The structures show evidence of deliberate excavation and construction using techniques that could move and shape solid rock on unprecedented scales. Some formations contain what appear to be massive infrastructure systems, including networks that could have distributed power, water, or information across continental distances. The engineering required to build such systems would exceed anything attempted by modern civilization, representing technological capabilities that suggest mastery over geological forces themselves. Most intriguingly, several of these underground complexes show evidence of having been deliberately sealed and abandoned. Entry points appear to have been filled with materials designed to prevent access while preserving the internal structures. This suggests their builders anticipated the need to protect their constructions from future geological changes or other threats. The discovery of these hidden architectural marvels raises profound questions about the relationship between intelligence and planetary stewardship. If previous civilizations developed technologies capable of surviving geological timescales, what happened to the species that built them? Did they transcend their physical existence, migrate to other worlds, or simply fade away despite their technological achievements? Carbon dating of organic materials found near these structures indicates ages stretching back millions of years, yet the construction techniques show sophistication that exceeds current human engineering capabilities. The builders understood geological processes well enough to create permanent installations that could withstand the forces that reshape continents over deep time. But perhaps the most unsettling discovery involves evidence that some of these ancient installations might still be active. Seismic monitoring has detected regular vibrations emanating from certain underground structures, following patterns too precise and coordinated to result from natural geological processes. The vibrations suggest mechanical systems that continue operating millions of years after their installation. Heat signature analysis reveals thermal anomalies around these sites that indicate ongoing energy consumption deep underground. The power sources appear to be self-sustaining, possibly drawing energy from radioactive decay, geothermal processes, or other long-term energy storage systems that don't require external fuel supplies. The possibility that ancient technological systems remain operational beneath our feet challenges every assumption about the permanence of civilization and the nature of intelligence itself. We may be living on a planet where previous inhabitants built infrastructure designed to outlast their own species, creating technological legacies that continue functioning long after their creators disappeared into the depths of geological time. Most disturbing of all are the atmospheric monitoring stations that appear to be tracking global environmental conditions with precision that rivals modern satellite surveillance. These installations show evidence of measuring atmospheric composition, ocean chemistry, and climate patterns across geological timescales, maintaining databases that span millions of years of planetary history. Electromagnetic surveys have detected what appear to be communication networks connecting these underground facilities across continents and ocean basins. The transmission systems use frequencies and modulation techniques that don't match any known natural electromagnetic phenomena, suggesting artificial communication protocols designed for long-range data exchange. If these systems are indeed still operational, they raise terrifying questions about surveillance and monitoring. Are we being observed by technological remnants of civilizations that vanished before our species even existed? The possibility that ancient artificial intelligence systems continue watching and recording human development from hidden installations creates a scenario more unsettling than any science fiction nightmare. But the underground infrastructure represents only part of a larger technological ecosystem that may have spanned the entire planet. Orbital debris analysis has revealed artificial objects in Earth's magnetosphere that don't match any known human space technology. These objects occupy highly stable orbital positions that would require sophisticated gravitational calculations to achieve and maintain over long periods. Spectroscopic analysis of these orbital artifacts reveals construction materials that don't match any known terrestrial minerals or human-manufactured alloys. The materials show properties optimized for the space environment, including resistance to radiation, micrometeorite impacts, and the extreme temperature variations of orbital flight that would destroy conventional satellites within years. Some of these objects appear to be in communication with ground-based installations, transmitting data using coherent electromagnetic signals that follow complex modulation patterns. The transmission schedules suggest automated systems operating according to predetermined protocols, possibly reporting environmental data or system status to receivers that may no longer exist. The implications extend beyond simple space debris. If previous Earth civilizations achieved orbital technology, they might have established permanent, space-based installations that continue operating millions of years after their creators disappeared. These could include manufacturing facilities, energy collection systems, and monitoring networks that function independently of Earth-based civilization. Recent discoveries of unusual mineral deposits on the Moon's surface add another layer to this cosmic mystery. Samples returned by various lunar missions contain isotope ratios and elemental concentrations that don't match the Moon's natural composition. Some materials appear to have been processed using techniques that require advanced metallurgy and chemistry. Lunar surface analysis has revealed geometric patterns that don't match typical impact crater or volcanic formation processes. These features show mathematical precision and systematic arrangement that suggests artificial construction rather than natural geological activity. The patterns appear designed to be visible from Earth, possibly serving as markers or beacons for purposes we can't comprehend. The Moon's lack of atmosphere and geological activity makes it an ideal preservation environment for artificial structures. Unlike Earth, where weather and tectonic forces destroy evidence within millions of years, the lunar surface remains virtually unchanged for billions of years. Any technology placed there during Earth's ancient past would remain perfectly preserved, waiting for discovery by future space missions. But perhaps the most chilling evidence comes from deep ocean trenches, Earth's most isolated and stable environments. Sonar mapping has revealed artificial structures on the ocean floor that show architectural complexity impossible to achieve through natural processes. These formations include geometric patterns, systematic layouts, and construction techniques that indicate deliberate engineering rather than random geological activity. The deep ocean provides exceptional preservation conditions for artificial materials. Cold temperatures, high pressure, and lack of oxygen prevent most forms of decay that would destroy surface installations. Structures built on the ocean floor could remain intact for millions of years, protected from the surface processes that eliminate evidence of past civilizations. Advanced, submersible missions have photographed what appear to be manufactured objects embedded in deep-sea sediments. These artifacts show machine surfaces, artificial joints, and construction materials that don't occur naturally in marine environments. Dating analysis indicates ages that predate human civilization by enormous margins, yet the construction quality suggests advanced manufacturing capabilities. Some deep ocean installations appear to have been mining operations that extracted minerals from the seafloor on industrial scales. The extraction patterns show systematic removal of specific materials using techniques that don't match any known natural process. Entire sections of ocean floor show evidence of having been excavated, processed, and then covered with sediment in ways that suggest deliberate concealment. The scope of these underwater installations suggests civilizations that achieved industrial capabilities exceeding anything attempted by modern humans. Moving and processing materials on the deep ocean floor requires technologies that can operate under crushing pressure while maintaining complex mechanical systems across vast distances. Most remarkably, some of these deep-sea installations show evidence of having been deliberately deactivated and sealed before abandonment. Access points appear to have been carefully closed using materials designed to prevent contamination while preserving internal structures. This systematic shutdown suggests their operators anticipated the need to protect their installations from future threats. Biological analysis of organisms living near these ancient sites reveals genetic modifications that don't match natural evolutionary processes. Deep-sea creatures in these areas show adaptations that appear designed for specific industrial functions, including abilities to process heavy metals, neutralize toxic compounds, and manufacture complex organic molecules. These genetically modified organisms represent perhaps the most sophisticated legacy of ancient technological civilizations. Unlike mechanical systems that eventually break down, biological systems can maintain themselves indefinitely through reproduction and adaptation. Previous civilizations might have created entire ecosystems of engineered species designed to support their industrial operations long after the civilizations themselves disappeared. The genetic modifications show evidence of advanced biotechnology that exceeds current human capabilities. The organisms contain artificial genetic circuits that operate like biological computers, processing information and responding to environmental changes in ways that suggest sophisticated programming rather than natural evolution. Some modified organisms appear designed to communicate with each other using biochemical signals that create information networks spanning entire ocean basins. These biological communication systems could represent the ultimate form of technological longevity, using living organisms as self-maintaining components of vast artificial ecosystems. The discovery of these engineered biospheres raises profound questions about the relationship between technology and biology. Previous civilizations appear to have achieved integration between artificial systems and living organisms that created hybrid ecosystems capable of surviving geological timescales. But the biological legacy extends beyond the deep oceans to terrestrial environments where genetic analysis has revealed similar patterns of ancient modification. Soil microorganisms in certain locations show artificial genetic sequences that appear designed for industrial applications, including mineral processing, waste disposal, and chemical synthesis. These terrestrial biological systems might represent the remains of ancient agricultural and industrial ecosystems that were engineered to support technological civilizations. The modified organisms continue performing their programmed functions millions of years after their creators vanished, maintaining soil chemistry and processing materials according to genetic instructions embedded in their DNA. Forest analysis in several locations has revealed tree species with genetic modifications that appear designed for construction and manufacturing applications. These trees produce wood with properties that exceed anything found in natural forests, including enhanced strength, chemical resistance, and specific cellular structures that suggest genetic engineering for industrial purposes. The systematic nature of these biological modifications indicates coordinated genetic engineering programs that spanned continents and involved thousands of species. Previous civilizations appear to have redesigned entire ecosystems to serve as biological factories, creating living systems that could manufacture materials, process waste, and maintain environmental conditions suitable for technological development. Archaeological excavation at sites containing these modified organisms has revealed additional evidence of sophisticated biotechnology. Microscopic analysis of soil samples shows artificial molecular structures that appear to be the remains of biological manufacturing systems. These molecular machines show design principles that exceed current nanotechnology capabilities. The integration of biological and technological systems suggests ancient civilizations achieved levels of scientific understanding that allowed them to blur the boundaries between living and artificial systems. They created hybrid technologies that combined the self-maintenance capabilities of biology with the precision and control of engineered systems. This biotechnological approach might represent the key to achieving technological permanence across geological timescales. While mechanical systems eventually fail and require maintenance, properly designed biological systems can maintain and repair themselves indefinitely through the natural processes of life itself. The evidence scattered across land, sea, air, and space paints a picture of technological civilizations that achieved capabilities we can barely imagine, then vanished so completely that only the most subtle traces remain for us to discover. Their legacy challenges every assumption about intelligence, technology, and the nature of civilization itself. But perhaps the most important question isn't whether these ancient civilizations existed, But what happened to them? Did they transcend physical existence through technological transformation? Did they migrate to other worlds or dimensions? Or did they face the same existential challenges that threaten human civilization today and fail to overcome them? Understanding the fate of our potential predecessors might provide crucial insights for navigating the challenges facing human civilization. If intelligence has emerged multiple times on Earth, then consciousness and technology might follow predictable patterns that could help us anticipate and prepare for our own future development. The search for ancient technological signatures continues, driven by the recognition that we may not be alone in the universe, and we may not even be alone in Earth's history. Each new discovery adds another piece to a puzzle that stretches across millions of years and challenges our understanding of what intelligence can achieve when given enough time to develop. The question of survival versus extinction leads us to examine one of the most disturbing patterns in the fossil record. Every few million years, Earth experiences mass extinction events that eliminate the majority of species in geological eye blinks. These aren't gradual evolutionary changes, but catastrophic collapses that reset the entire trajectory of life on our planet. What makes these events particularly unsettling is how precisely they coincide with the mysterious technological signatures we've been investigating. The Permian extinction 252 million years ago eliminated 96% of marine species and 70% of terrestrial life in less than 20,000 years. For a natural process to cause destruction, this rapid and complete challenges every model of environmental change we understand. Volcanic activity and climate shifts typically take hundreds of thousands of years to trigger ecosystem collapse. Yet the fossil evidence shows species vanishing simultaneously across different continents and environments, as if coordinated by some external force. Rock layers from this period contain carbon isotope ratios that match exactly what we see from massive industrial fossil fuel burning. The scale suggests carbon release equivalent to combusting every known coal, oil, and natural gas deposit on Earth within a few thousand years. No natural process could mobilize this much stored carbon so quickly, yet the chemical signature appears consistently across global sediment samples from the extinction boundary. Even more troubling are the trace metal concentrations found in these same rock layers. Lead, mercury, and copper appear in quantities that exceed what volcanic eruptions or asteroid impacts typically produce by factors of hundreds. The metals show distribution patterns consistent with atmospheric dispersal from multiple point sources, suggesting industrial activities operating simultaneously across vast geographical areas. The biological selectivity of these extinction events defies natural explanation. Species with similar ecological requirements show dramatically different survival rates for reasons that remain mysterious. Some groups that should have been vulnerable to environmental stress survived almost unchanged, while others that appeared well adapted went extinct completely. This targeting suggests extinction mechanisms that operated according to criteria beyond simple environmental tolerance. Similar patterns appear in other major extinction events throughout Earth's history. The Ordovician extinction 445 million years ago shows the same combination of rapid timing, selective targeting, and chemical signatures that don't match natural processes. Ocean chemistry changed so dramatically during this event that marine organisms with calcium carbonate shells died within thousands rather than millions of years. The speed of these changes suggests concentrated acid release rather than gradual atmospheric carbon dioxide buildup from volcanic sources. Natural processes that acidify ocean water operate over much longer timescales than the geological evidence indicates. Something was dumping enormous quantities of acid or acid precursors directly into the marine environment. Deep ocean sediment cores from extinction boundaries contain microscopic particles that appear to be the remains of engineered microorganisms. These particles show evidence of artificial genetic modification and manufacturing techniques that wouldn't be developed by humans for hundreds of millions of years. Their presence suggests biological weapons deployed on a planetary scale during extinction events. The timing correlation between technological signatures and mass extinctions creates a disturbing hypothesis. Previous civilizations might have triggered their own destruction through industrial activities that destabilized planetary environmental systems. The chemical fingerprints we're finding could represent the final gasps of technological societies that pushed their planet beyond ecological breaking points. But extinction events also create opportunities. Each mass extinction is followed by explosive evolutionary radiation, where surviving species rapidly diversify to fill empty ecological niches. These periods of accelerated evolution produce new body plans and capabilities that wouldn't have emerged under normal competitive conditions. Intelligence itself might be a product of post-extinction evolutionary experimentation. The mammalian radiation that followed the dinosaur extinction demonstrates how catastrophic events can redirect evolution toward consciousness. Small mammals that survived the impact winter diversified rapidly into ecological roles previously occupied by reptiles. Within just a few million years, they developed complex social behaviors, advanced sensory capabilities, and eventually, the cognitive abilities that led to human intelligence. This pattern might repeat throughout Earth's history. Each extinction event eliminates dominant species, while creating evolutionary opportunities for intelligence to emerge in new forms. Technological civilizations develop, alter their environment, trigger ecological collapse, and disappear. The cycle begins again with whatever survivors remain, eventually producing new forms of consciousness that face the same existential challenges. Archaeological evidence supports this cyclical interpretation. Geological formations from different time periods show similar technological signatures separated by millions of years, suggesting multiple independent developments of advanced civilization. Each appears to have reached sophisticated levels of nuclear technology, atmospheric manipulation, and biological engineering before vanishing from the record. The time gaps between these technological episodes match the recovery periods following major extinction events. It takes roughly 5 to 10 million years for ecosystems to fully recover their biodiversity after catastrophic collapse. This time frame also corresponds to the intervals we see between different sets of technological signatures in the geological record. If this pattern holds, human civilization represents just the latest iteration in a cycle that is repeated throughout Earth's history. We're developing the same technologies, facing the same environmental challenges, and approaching the same critical decision points that determined the fate of our predecessors. The question becomes whether we can learn from their apparent failures or are destined to repeat them. The answer might lie in understanding exactly what went wrong with previous civilizations. Did they destroy themselves through warfare using the nuclear technologies they developed? Did they trigger runaway climate change through industrial activities that destabilized atmospheric chemistry? Or did they face external threats from space that overwhelmed even their advanced capabilities? Asteroid impact evidence suggests that some extinction events resulted from cosmic catastrophes beyond any civilization's control. The dinosaur extinction clearly involved a massive space rock impact that no terrestrial technology could have prevented. But other extinction events show no evidence of extraterrestrial causes, pointing toward internal civilizational collapse as the primary mechanism. The nuclear signatures we've discovered provide crucial clues about how these collapses might have unfolded. Isotope patterns in some rock layers match what large-scale nuclear warfare would produce, suggesting that previous civilizations might have destroyed themselves through atomic conflicts. The global distribution of these signatures indicates planetary-scale nuclear exchanges that would have rendered vast areas uninhabitable. Climate engineering evidence points toward another failure mode. Previous civilizations appear to have developed sophisticated atmospheric manipulation technologies that could control global temperature and weather patterns. But the same technologies that enabled environmental management could also trigger runaway feedback loops if misused, or if control systems failed. Biological warfare signatures suggest a third possibility. Ancient genetic modifications show evidence of weaponized organisms designed to target specific species or ecological systems. These biological weapons could have been deployed during conflicts between different civilizations or different groups within the same civilization, leading to ecological collapse that eliminated both attackers and targets. Each potential failure mode offers lessons for human civilization as we develop similar technologies. Nuclear weapons, climate engineering, and genetic modification all represent double-edged capabilities that could either ensure our survival or guarantee our extinction, depending on how wisely we use them. The cyclical pattern also suggests that intelligence faces predictable challenges as it develops technological capabilities. The same scientific discoveries that enable spaceflight and planetary management also create weapons of unprecedented destructive power. Every technological civilization must navigate the transition from planetary to interplanetary existence while avoiding self-destruction through misuse of the very technologies that make expansion possible. Current human development shows alarming parallels to the patterns we see in ancient technological signatures. We're rapidly developing nuclear technology, experimenting with climate engineering, and beginning to modify biological systems on unprecedented scales. Our atmospheric chemistry is changing at rates that match some of the fastest environmental transitions recorded in the geological record. The acceleration of technological development creates additional risks that previous civilizations might not have faced. Modern human society is developing multiple, potentially civilization-ending technologies simultaneously, compressed into timeframes too short for social and political systems to adapt. This technological convergence might represent a particularly dangerous phase that explains why so few civilizations seem to survive the transition to long-term stability. But human civilization also possesses advantages that our predecessors might have lacked. Global communication networks enable unprecedented coordination of human activities. Scientific understanding of planetary systems allows us to monitor and potentially control environmental changes. Most importantly, we're beginning to recognize the patterns that led to previous civilizational collapses. Archaeological investigation of ancient technological sites should become a top priority for understanding survival strategies. If previous civilizations left messages or knowledge caches for future intelligence, discovering these repositories could provide technologies or wisdom essential for navigating existential risks successfully. The biological modifications we've found suggest that some ancient civilizations might have attempted to preserve their knowledge through genetic encoding in surviving species. DNA can store information with remarkable density and stability across geological timescales. Systematic analysis of genetic sequences in ancient organisms might reveal encoded messages from civilizations that anticipated their own destruction. Underground installations might serve similar purposes as technological time capsules designed to survive mass extinction events. The sealed chambers and preserved systems we've discovered could contain archives of scientific knowledge, cultural information, and warnings about the challenges that destroyed their creators. Space-based installations offer another potential source of preserved knowledge. Unlike surface installations that face constant erosion and recycling, orbital facilities could remain intact for millions of years in the vacuum of space. Advanced telescopes and space missions might eventually discover ancient satellites or space stations that contain databases of civilizational memory. The search for this preserved knowledge becomes more urgent as human civilization approaches its own potential crisis points. Climate change, nuclear proliferation, and artificial intelligence development are accelerating toward thresholds that could determine humanity's long-term survival prospects. Understanding how previous civilizations faced similar challenges might provide crucial guidance for navigating these existential risks. But time is working against us. The same geological processes that preserve evidence of ancient civilizations also continue destroying it at accelerating rates. Climate change, tectonic activity, and human development threaten to eliminate crucial evidence before we learn to recognize and interpret what we're looking for. The ultimate irony is that human civilization might face the same fate as our predecessors, not because we failed to learn from their mistakes, but because we discovered their existence too late to benefit from their experience. The evidence of ancient technological civilizations is scattered across the planet, waiting to be found and decoded. But our window for discovery might be closing faster than our ability to conduct the necessary research. Each new piece of evidence adds urgency to the investigation. We're not just studying ancient history, but examining case studies in civilizational survival and failure that could determine whether human consciousness represents a brief flicker in cosmic history or the emergence of intelligence mature enough to break the cycle of rise-collapse that has characterized Earth's technological species. The stakes couldn't be higher. If we're right about the existence of previous civilizations, then intelligence has emerged multiple times on Earth only to destroy itself through predictable failure modes. Understanding these patterns and developing strategies to avoid them might represent the most important scientific endeavor in human history. The question isn't whether we can find definitive proof of ancient civilizations, but whether we can learn from their apparent failures quickly enough to avoid repeating them. The geological record contains the ultimate survival manual, written in stone and isotopes by species that face the same challenges we're approaching today. Their success or failure in navigating existential risks could determine whether human civilization joins the ranks of vanished intelligence or becomes the first to achieve permanent stability across geological timescales. The evidence suggests that the test facing human civilization isn't unique, but part of a recurring pattern that has challenged every technological species in Earth's history. How we respond to this test will determine not just our own survival, but whether intelligence itself has a permanent future on this ancient, repeatedly inhabited world. The answer might already be staring us in the face, hidden in plain sight within our own genetic code. Recent breakthroughs in ancient DNA analysis have revealed something extraordinary lurking in the chromosomes of seemingly ordinary organisms. Genetic sequences that don't belong to any known natural evolutionary pathway, appearing across multiple species with the precision of deliberate engineering rather than random mutation. Scientists extracting DNA from permafrost samples in Siberia discovered genetic material from organisms that lived hundreds of thousands of years ago. Within these ancient sequences lie modifications that exceed current human genetic engineering capabilities by enormous margins. The alterations show evidence of systematic design, with artificial chromosomes containing information storage densities that dwarf our most advanced biological computers. These genetic modifications appear simultaneously across unrelated species on different continents, suggesting coordinated biological manipulation on a planetary scale. Natural evolution could never produce such synchronized changes across diverse organisms within identical timeframes. The modifications follow consistent patterns that indicate a single source of technological intervention rather than multiple independent evolutionary adaptations. The engineered sequences include enhancement protocols that would benefit technological civilizations, increased cognitive processing in various animal species, enhanced disease resistance that protects against industrial toxins, extended lifespans that would support long-term technological development. Most remarkably, adaptations for surviving in artificially modified atmospheric conditions that don't exist naturally on Earth. Deep analysis reveals that some organisms carry genetic circuits designed to respond to synthetic chemical triggers that haven't existed since ancient geological periods. These biological switches appear programmed to activate under specific environmental conditions, suggesting they were designed to support civilizations that could precisely control their planetary environment through technological means. The information storage capacity embedded in these ancient genetic modifications exceeds anything current biotechnology can achieve. Single chromosomes contain data equivalent to entire digital libraries, encoded using molecular structures that remain stable across millions of years. The encoding methods use properties of DNA that we're only beginning to understand, suggesting scientific knowledge far beyond our current biological sciences. Some genetic sequences appear to contain actual technical specifications for advanced technologies, mathematical constants encoded in base pair arrangements, star charts mapped onto chromosome structures, what appear to be blueprints for energy generation systems that don't match any known engineering principles. These biological hard drives were apparently designed to preserve crucial knowledge across geological timescales when all other storage methods would fail. The most unsettling discovery involves dormant genetic programs found in modern organisms that can be artificially activated in laboratory conditions. When triggered, these sleeping sequences cause contemporary species to express traits that would have been useful to technological civilizations, but serve no apparent purpose in natural environments. Animals develop tool-using capabilities they never display in the wild. Plants produce chemical compounds that don't occur in nature, but would be valuable for industrial applications. This suggests that current Earth ecosystems might be descended from extensively modified biospheres created by previous civilizations. The organisms around us could be the evolutionary descendants of biological machines designed to support technological societies that vanished millions of years ago. We might be living in a world shaped by artificial selection programs that created entire ecosystems optimized for intelligence and industry. But the genetic evidence points toward an even more disturbing possibility. Some modifications appear designed specifically to guide the evolutionary development of intelligence itself. Genetic changes that accelerate cognitive development while suppressing traits that might interfere with technological advancement. These modifications suggest previous civilizations might have been actively managing evolution to ensure intelligence would eventually re-emerge after their own extinction. The implications stretch far beyond biology into the realm of cosmic inheritance. If ancient civilizations encoded their knowledge in DNA and guided evolutionary processes to recreate intelligence, then human development might not represent natural evolution at all. We could be the intended products of genetic programming initiated millions of years ago by predecessors who anticipated their own destruction and prepared for their eventual replacement. This biological legacy system would represent the ultimate form of technological continuity across geological time. While physical artifacts crumble and even nuclear signatures decay, genetic information can be copied and preserved indefinitely through natural reproduction. Previous civilizations might have achieved a form of immortality by encoding themselves into the evolutionary trajectory of life itself. Archaeological analysis supports this interpretation. Sites containing unusual genetic modifications also show evidence of sophisticated biotechnology installations. Microscopic examination reveals artificial molecular structures that appear to be the remains of genetic engineering laboratories. These facilities show evidence of large-scale DNA manipulation using techniques that exceed current human capabilities. The precision of ancient genetic modifications suggests previous civilizations achieved complete mastery over biological systems. They could design organisms for specific purposes, create new species from scratch, and modify existing life forms with the same precision we use to engineer electronic circuits. This biological technology might have been their primary approach to environmental management and resource production. Carbon dating of organic materials associated with these genetic engineering sites indicates multiple episodes of biotechnological activity separated by millions of years. Each episode shows progressively more sophisticated genetic modifications, suggesting that successive civilizations built upon the biological technologies left by their predecessors. The pattern implies a form of technological evolution that transcends individual civilizations. Each intelligent species that emerged on Earth inherited the genetic modifications created by previous inhabitants then added their own improvements before vanishing and leaving the enhanced biological systems for their successors to discover and develop further. This biological inheritance model could explain the accelerating pace of evolution that produced human intelligence. Instead of starting from primitive ancestors, our lineage might have benefited from millions of years of genetic optimization performed by previous technological civilizations. The rapid development of human cognitive abilities over the past few million years could represent the activation of genetic programs that were installed long before our species existed. Modern human genetics shows anomalies that support this hypothesis. Our DNA contains sequences that appear too complex to have evolved through natural selection alone. Genetic elements that seem designed for specific cognitive functions rather than gradually accumulated through random mutation and environmental pressure. These sequences might be the most recent additions to a genetic enhancement program that has been operating for millions of years. The discovery of these genetic time capsules raises profound questions about human autonomy and the nature of consciousness itself. If our intelligence results from genetic programming initiated by previous civilizations, then our thoughts, discoveries, and technological achievements might be following predetermined pathways established by our predecessors. But the genetic evidence also suggests we're approaching a critical decision point that previous civilizations faced. The same biotechnological capabilities that allowed ancient species to encode their knowledge in DNA also enabled them to modify organisms for destructive purposes. Genetic warfare signatures found in extinction boundary layers suggest that biological weapons played a role in the collapse of previous technological civilizations. Current human development of genetic engineering technologies mirrors the patterns we see in ancient biological modifications. We're beginning to modify organisms for industrial purposes, enhance cognitive abilities through genetic manipulation, and develop biological systems that could theoretically survive and operate across geological timescales. The question becomes whether we'll use these capabilities more wisely than our predecessors. The genetic inheritance system might also provide the key to breaking the cycle of civilizational rise and collapse. If we can decode the knowledge encoded in ancient DNA sequences, we might access technologies and wisdom accumulated across millions of years of intelligent development. This biological library could contain solutions to the existential challenges that destroyed previous civilizations. Recent advances in genetic archaeology have begun systematic efforts to identify and decode information stored in ancient DNA sequences. Artificial intelligence systems designed specifically for genetic analysis are revealing encoded messages that were invisible to conventional DNA sequencing methods. These messages appear to contain technical specifications, warnings about civilizational risks, and guidance for achieving long-term technological stability. The race to decode this genetic inheritance becomes more urgent as human civilization approaches the same technological thresholds that apparently destroyed our predecessors. Climate engineering, nuclear technology, and biological manipulation represent the same capabilities that previous civilizations developed before vanishing from the geological record. Understanding how they used these technologies and why they failed could determine whether human intelligence represents another brief episode in Earth's cycle of technological rise and fall, or the first civilization to achieve permanent success. But decoding ancient genetic messages requires recognizing that we might not be the independent actors we assume ourselves to be. Our scientific discoveries, technological developments, and even our current investigation into previous civilizations might be following pathways established by genetic programming initiated millions of years ago. We could be unwitting participants in a vast biological experiment designed to recreate and improve upon the technological achievements of our vanished predecessors. The ultimate test of human intelligence might not be developing new technologies, but recognizing our place in this ancient genetic inheritance system and choosing whether to continue following predetermined pathways or forge genuinely independent approaches to technological development and planetary stewardship. The DNA in our cells carries the memories of civilizations that face the same choices we're approaching today. Their successes and failures are written in the genetic code that shapes our thoughts and drives our technological ambitions. Understanding this biological legacy could represent either humanity's greatest opportunity or its final trap, depending on whether we can learn from the encoded wisdom of our predecessors, or are doomed to repeat their mistakes through genetic programming we don't yet recognize or understand. The question of genetic inheritance leads us to examine one of the most chilling discoveries hidden in Earth's fossil record. Scattered throughout sedimentary layers that formed millions of years ago, paleontologists have found microscopic structures that shouldn't exist. These aren't fossilized cells or organic remains, but rather artificial constructs that appear to be manufactured components of technologies we can barely comprehend. Under electron microscopy, these structures reveal geometric precision that defies natural formation. Perfectly spherical capsules with walls exactly 50 nanometers thick. Crystalline matrices arranged in mathematical patterns that follow engineering principles rather than biological growth. Most disturbing are the microscopic gears, springs, and mechanical elements that show clear evidence of deliberate design and manufacturing. The materials themselves challenge our understanding of ancient chemistry. These microscopic machines are constructed from alloys that require temperatures and pressures exceeding anything natural geological processes could produce. Spectroscopic analysis reveals elemental compositions that include rare earth metals concentrated in ratios that don't occur anywhere in nature. Carbon dating of surrounding organic matter places these technological fragments in geological contexts spanning hundreds of millions of years. Yet the manufacturing precision suggests industrial capabilities that exceed current human nanotechnology by enormous margins. We're looking at machine components smaller than viruses but more complex than anything in our most advanced laboratories. The distribution pattern tells an even stranger story. These microscopic artifacts appear in sedimentary layers across every continent, suggesting global manufacturing and distribution networks that operated when Earth's landmasses were arranged completely differently than today. The consistency of design across such vast geographical and temporal ranges indicates standardized production methods maintained across millions of years. But the most unsettling aspect is what happens when these ancient machines are exposed to specific electromagnetic frequencies. Laboratory experiments have shown that some components begin exhibiting mechanical responses when subjected to radio waves at particular wavelengths. Microscopic gears start rotating. Crystalline structures begin oscillating in synchronized patterns. These million-year-old devices appear to retain some form of operational capability. The electromagnetic activation suggests these weren't passive components but active elements in larger technological systems. The frequencies that trigger responses don't match any natural electromagnetic phenomena, implying they were designed to interface with artificial control systems that operated on wavelengths specifically chosen for technological applications. Advanced analysis has revealed that some of these microscopic machines contain information storage elements denser than anything achievable with current technology. Individual crystalline structures appear capable of storing data equivalent to modern computer hard drives, all compressed into volumes smaller than bacterial cells. The storage medium shows no signs of degradation despite millions of years of burial. The information itself remains largely unreadable with current technology. But partial decoding has revealed what appear to be technical specifications and operational instructions. Mathematical formulas that describe physical relationships we're only beginning to understand. Engineering diagrams for devices that don't match any known technology. Most intriguingly, what appear to be maps showing stellar positions that don't correspond to current astronomical observations. These stellar charts might represent the most significant discovery of all. If ancient civilizations were mapping star positions, They possessed astronomical knowledge that required sophisticated observation technologies. But the stellar arrangements shown in these charts don't match any configuration visible from Earth during known geological periods, suggesting the maps might represent views from other locations entirely. The possibility that previous Earth civilizations achieved interstellar travel capabilities fundamentally changes our understanding of technological development and civilizational scope. If they could travel between stars, their disappearance from Earth might not represent extinction, but rather migration to other worlds where their descendants might still exist. This interpretation gains support from recent discoveries in Earth's upper atmosphere, where high-altitude research balloons have detected artificial particles that don't match any known terrestrial or human-made materials. These particles show evidence of controlled fusion processes and exotic matter configurations that suggest manufacturing techniques beyond our current capabilities. Isotope analysis reveals these atmospheric particles contain elements that don't occur naturally on Earth, but match theoretical predictions for materials that could only be produced in zero-gravity manufacturing environments. The particles appear to be debris from industrial processes conducted in space, possibly in orbital facilities that operated millions of years ago. The orbital debris represents just one component of what might be a vast space-based infrastructure left behind by previous civilizations. Deep space monitoring systems have detected regular radio pulses originating from the outer solar system that follow patterns too precise to represent natural astronomical phenomena. These signals suggest automated systems that continue broadcasting across interplanetary distances. Spectroscopic analysis of these signals reveals complex modulation patterns that appear to carry encoded information. The transmission schedules follow mathematical sequences that indicate artificial intelligence systems designed to operate autonomously for millions of years. These could be automated beacons left by civilizations that achieved interstellar expansion capabilities. The signals show characteristics of adaptive communication protocols that modify their transmission parameters in response to changing conditions. This suggests the broadcasting systems possess some form of artificial consciousness capable of learning and responding to environmental changes over geological timescales. We might be receiving messages from machine intelligences that have been operating continuously since before complex life emerged on Earth. But the space-based evidence points toward an even more staggering conclusion. If previous civilizations developed interstellar travel and established colonies on other worlds, Earth might represent just one node in a galactic network of intelligent species that has been operating for millions of years. Our planet could be a recurring stop in an interstellar civilization cycle where intelligence periodically emerges, develops space travel, and joins the larger galactic community. This model would explain why technological civilizations seem to vanish from Earth's geological record. They don't go extinct, but rather graduate to interstellar status and migrate to other worlds where resources are more abundant and environmental conditions more stable. Earth serves as a nursery world where intelligence repeatedly develops until it achieves the technological maturity needed for galactic citizenship. The microscopic machines embedded in our geological record might represent gifts or tools left behind by departing civilizations to assist their successors. These technological seeds could be designed to activate when emerging civilizations reach specific developmental milestones, providing crucial knowledge and capabilities needed for the transition to interstellar existence. Recent experiments with electromagnetic activation of ancient microscopic components have produced unexpected results. Some devices begin emitting coherent signals when powered, apparently attempting to establish communication with systems that no longer exist. Others show evidence of self-repair mechanisms that can restore damaged components using ambient materials from their environment. The most sophisticated specimens appear to be self-replicating manufacturing systems that can produce copies of themselves when provided with appropriate raw materials. These molecular factories represent technology that could theoretically bootstrap an entire industrial civilization from microscopic beginnings. Previous civilizations might have embedded their complete technological knowledge in self-replicating systems designed to assist future intelligence. But accessing this embedded knowledge requires understanding activation protocols that were presumably known to the civilizations that created these systems. The electromagnetic frequencies that trigger basic responses might represent only the simplest level of interaction. More complex activation sequences could unlock advanced capabilities, including manufacturing instructions for macroscopic technologies. The search for these activation codes has become a priority for researchers investigating ancient technological signatures. If we can learn to properly interface with these microscopic systems, we might gain access to millions of years of accumulated scientific and technological knowledge. This could provide solutions to current human challenges, including energy production, space travel, and environmental management. However, the same technologies that offer unprecedented opportunities also pose existential risks. Self-replicating systems that operate beyond human control could theoretically consume Earth's entire biosphere if their programming contains errors or if they're activated incorrectly. Previous civilizations might have faced similar risks when developing these technologies. The microscopic artifacts scattered throughout our geological record might represent both the greatest gift and the ultimate test left by our predecessors. They offer access to technologies that could solve humanity's greatest challenges and enable our transition to interstellar civilization. But they also require wisdom and caution that previous civilizations might have lacked, leading to their apparent disappearance from Earth's surface. Understanding the fate of these vanished civilizations becomes crucial for determining how to safely access their technological legacy. Did they successfully transition to interstellar existence? Or did they destroy themselves through misuse of the same technologies they embedded in Earth's geological record? The answer might determine whether human civilization represents another stepping stone toward galactic intelligence or the final chapter in Earth's long history of technological experimentation. The evidence suggests we're approaching a critical decision point that has faced every technological civilization in Earth's history. We can continue developing technologies independently, facing the same risks that apparently eliminated our predecessors, or we can attempt to access the knowledge they left behind with all the opportunities and dangers that such access might entail. The choice we make could determine not just human civilization's survival, but whether Earth continues its cycle of producing technological species or finally achieves its apparent purpose as a launching point for intelligence that transcends planetary boundaries and joins the larger community of galactic civilization. But before we can make that choice, we need to understand what we're truly dealing with. The microscopic artifacts represent just the visible portion of a technological legacy that might extend far beyond anything we've discovered so far. Hidden throughout Earth's geological layers, integrated into biological systems, and embedded in the very structure of our planet's development, lie the complete archives of civilizations that achieve capabilities we're only beginning to imagine. The question isn't whether we can find this ancient knowledge, but whether we're wise enough to use it responsibly when we finally gain access to technologies that could either elevate human civilization to cosmic significance or eliminate us as thoroughly as they apparently eliminated every previous attempt at technological intelligence on this repeatedly inhabited world. The answer might lie in understanding what happened to them, and the clues are more disturbing than we ever imagined. Deep beneath the ice sheets of Antarctica, ground-penetrating radar has revealed structures that defy every natural explanation. These aren't random geological formations, but geometric patterns spanning hundreds of miles underground, showing architectural precision that would challenge our most advanced engineering capabilities today. The structures appear deliberately designed to survive the formation of the ice sheet itself, using construction principles that account for millions of years of glacial pressure and movement. Three-dimensional mapping reveals internal chambers, systematic layouts, and what appear to be massive infrastructure networks that could have distributed power or information across continental distances. But here's what makes your blood run cold. Some of these installations appear to still be active. Seismic monitoring has detected regular mechanical vibrations emanating from specific locations, following patterns too precise to result from natural geological processes. Heat signature analysis reveals ongoing energy consumption deep underground, suggesting power systems that have operated continuously for millions of years without any external fuel source. The implications are staggering. We might be living on a planet where previous inhabitants built technological infrastructure designed to outlast their own species. These systems could be monitoring global environmental conditions with precision that rivals our most advanced satellite networks, maintaining databases that span millions of years of planetary history. Even more unsettling are the electromagnetic signatures detected around these sites. Communication networks appear to connect underground facilities across continents and ocean basins, using frequencies and transmission protocols that don't match any known natural phenomena. If these systems are operational, they raise terrifying questions about surveillance and observation that we're not prepared to confront. The orbital evidence adds another layer of mystery. Space debris analysis has revealed artificial objects in Earth's magnetosphere that don't match any human technology. These objects occupy gravitationally stable positions that would require sophisticated calculations to achieve and maintain over geological time periods. Spectroscopic analysis shows construction materials optimized for space environments, including resistance to radiation and temperature extremes that would destroy conventional satellites. Some of these objects appear to be communicating with ground-based installations, transmitting data using complex modulation patterns that suggest automated systems operating according to predetermined protocols. We might be surrounded by a network of ancient monitoring stations that continue reporting to receivers that may no longer exist, or worse, to civilizations that have simply moved beyond our ability to detect them. The evidence is undeniable. From nuclear reactors that operated 2 billion years ago, to microscopic machines embedded in million-year-old rock, from genetic modifications that exceed our current capabilities to underground installations that still pulse with ancient energy, we're confronting the possibility that Earth has hosted technological civilizations repeatedly throughout its deep history. We might not be the first intelligent species to emerge on this planet. We might be the latest survivors in a cycle that has repeated for millions of years, each civilization rising to technological heights before vanishing into geological time, leaving only the faintest whispers of their existence for us to discover. But here's the most chilling realization of all. If we're right about these ancient civilizations, then we're approaching the same critical thresholds that apparently destroyed our predecessors. The same technologies we're developing today, the same environmental challenges we're facing, the same existential risks that threaten our survival. The question isn't whether previous civilizations existed. The question is whether we're wise enough to learn from their apparent failures, or whether we're destined to become another forgotten chapter in Earth's hidden history of technological intelligence that burned bright and then disappeared forever into the darkness of deep time.